Okay, that was everything for introduction. Now we're moving into another section, which is research methods. It's not my favorite section to teach. I shouldn't say that, but it's all about scientific method and stuff like this. I'm going to briefly go through some basic terms that you'll need to know for the test, and later on when we talk about studies or how we study psychology, you'll know what I'm talking about. Okay, 4 goals of psychology research. I make it into this little thing called DECA, if I can get it to come on here, DECA. If I go to the psychologist and show up to the psychologist, he's going to say, why are you here? Describe why you're here, Tim. The reason I have a dog on here is because I like Caesar Milan, the dog whisperer. If I bring my dog to Caesar, he's like, why'd you bring your dog to me, Tim? What is he doing? Can you describe the problem? Well, he pees on my stuff all the time when I leave the house, and he chews up all my stuff when I leave the house every day. It's like, oh, okay. Well, let me try to give you an explanation for that. You would do the same thing if I showed up to the psychologist and say, I don't feel very good, I'm depressed, anxious. Can you explain why? You know what I mean? Maybe it's your family background, your physiology, this, that, or the other. Okay, so back to the dog example. He's like, okay, well, I'll tell you why he does it, Tim. He's got separation anxiety. He's mad because you left. He doesn't like it. I don't want to get into the secret life of pets like Tiny Dog. But anyway, then control. Can you control that? Because I don't want him tearing up my stuff and peeing on my stuff. It's like, yeah, I think I can control it if we apply some things we know about psychology. Okay, so hopefully DECA made sense. If I show up to the psychologist, I'm depressed, maybe he tells me why. Can you control it with medicine, which is one of my big issues, or therapy or something? How are we going to control this? And so those are the 4 steps. Let me get all this off of here. One of the other things I want you to know for the test is some research is basic. You're just trying to get a general basic understanding, and it's usually done in a laboratory. Those are the 2 features of basic. General understanding in the laboratory. Most science is done like this because the real world is messy. Applied research is done in the real world. Why? Because we have to use psychology like Caesar Milan to solve the dog problem. Okay, so this is why I do like applied psychology, but it's not as scientific because you can't control all the other possible factors that might come into play. Okay, so again, basic, general in the lab, applied, specific, because I'm trying to apply psychology and use it in the real world. I want you to know about is quantitative research is what most scientists prefer. Quantitative, you might think of numbers when you hear the word quantitative, quantity, that's where it comes from. Qualitative research we do as well, but qualitative research is not what you think quality, it's more like your qualities, like what color hair do you have? Are you nice or mean or things like this where we can't completely quantify those things. Now my example I usually give in class because we're not there, sometimes it's not as good on the web as it is in class, is height. I can say that you're 6'8". That would quantify your height. Or I could say you're really tall. Both convey information about your height, but this one we call more accurate. But there are certain things that I think are hard to quantify, like if you have red hair. You know what I mean? If I say you have red hair, that's the best way to say it. There's no number I need to associate with that. Quantitative research, just keep in mind I have these cutesy numbers on here. There's 4 kinds that I was going to go through right here. Number 1 is naturalistic observation. That's just like watching people or animals in the wild. I love these shows. I watch Planet Earth 2, and now I have Seven Worlds, One Planet. And I watch how they watch the animals and count what they do and scientifically track them. And so you can observe people in their natural habitat. And that's great because they're acting natural, but it's also messy. Now, another thing we do in the real world is to gather surveys on people. And if you think about a survey, it's usually like on a scale of 1 to 10, how much did you like this or dislike this? And in the middle, it's like in between, right? And so they make you quantify that. But I would also argue if you filled out a survey for my class and if you liked it or not, at the end, if I said, what would you do to improve this class? I don't think you would say 57. You would probably say, I didn't like this or that. You would verbalize it qualitatively versus quantitatively. So surveys do both. Now, the third kind that I want to spend more time on is correlational research. I don't know, you might not like math. I love math. Math is just another language. But two things relate. How do two things relate? That's why on graphs, at least in class, you have an x-axis, right, and a y-axis. How do two things relate? And you can have a relationship this way, or kind of no relationship in here. Now, correlational coefficient can go from -1 all the way up to +1. And 0 means no relationship. 1 is perfect either way. Now, if you have a 0.7, that's not like 70%, but I'm just going to say for this class, just keep it in mind. There's a strong relationship between x and y versus 0.1 is a weak relationship. Now, if all this confused, off of this and go to a simple example. X, how much do you study? Y, what is your test grade? Those two effing things better be correlated. The more you study, the higher your test grade. And if you look at it, each person that studied only 1 hour, each one of these dots is a person. I studied 1 hour and got this grade, or I studied, 5 hours and got this grade over here. And so you can see how different people get different, grades. Now, this isn't realistic because there's going to be some people that don't study at all and they get a grade up here, or people that study a lot and they get a grade down here. But I've made it phony data to almost be a correlation of 1. Positive is this: as I study more, my test grade rises. As I study less, my test grade falls. They rise and fall together. That's the positive sign. An example of the reverse. Now I should put my Xbox One on here, but PS4, I have it on here. The more I play my PS4, the less my test grade, is. So more over here, I have Y, test grade, X over here. As this goes up, how much I gain, my test grade is going down, right? The more I gain, the less my test grade is. They were correlated. I switched it too fast at -0.98. Still a really high correlation on that other slide, but it's negative because they seesaw, and the relationship goes like this instead of this. Body weight and test grade is my example of no relationship. Doesn't matter if you're light or heavy, you can make a bad or a good grade. There's no relationship. Now, this for a minute. See, I come back to this if all that confused you. Here's Y and here is X. I don't know if you've taken this in your math class. I'm just going to assume you probably had to, but I've got this real strong relationship here, right? Because I have all these people that I graphed out. Now, usually in math class, they make you fit this line through here. And so now I can see where it's a positive relationship. They both rise and fall together, right? If the line was the other direction, you would see a different kind of relationship. Now, one of the things I talk a lot about is this little formula right here, because now I've become powerful in psychology all of a sudden. I can start to predict your test grade from how much you study with this line of best fit. This is regression. And so M right here relates to how strongly the things are correlated, which would be the slope of the line, and B is just where I start the line, right? And so the more strong the relationship is, the more strong this M is, which makes this Y equals X. If this was 1, then Y equals X, right? I don't know if that confused you or not. I'm not going to ask you that on the test, of course, but this is where psychology becomes powerful. Because if you say, hey, Tim, I studied for 2.5 hours, and I go, well, I don't have any data. It's like, well, based on my line, I would guess right over here. I didn't do a very good line right there, but you get the point. Now, if I had more data on you, I could do multiple regression. I could have a lot of X's. Like how much hours do you work? How much did you study? Do you have kids or not? All these different things. And then I would have a better estimate of your test grade. This is what I used to do for a living, and if you think you're not affected by this, that's what a FICO score is. Your credit score, they take all these things, how many credit cards, how many 30 days late, do you own a house, all these things, they cook it into a number between 0 and 1,000. But I would say that's like a percentage, 0 and 1. If my credit score is like 850, that's closer to 1. That means I'm less likely to charge off and skate off with your money. But if it's 550, that's like a 50-50 chance the bank is going, I don't know. And so that's how they try to predict your financial behavior based on your past behavior in the financial arena. I hope I made sense right there. You don't have to know that for the test, but with correlation, do remember it can go between 0 and 1, and the stronger the relationship, the closer this is to 1. Okay, so last thing that I wanted to talk about, a lot of times you go, oh, this is great. I can predict test grades, I can predict all kinds of things, but one of the things you want to do but you can't is say one caused the other. Video games is the best example. Okay, I'm just not going to play video games. Where's my 100 on the test? It's like, well, there's more factors involved than just I don't play video games and that causes me to get a good test grade. And so I bet this is the example I'm going to leave you with right now is ice cream sales and drownings. These two things are highly correlated. The more ice cream that's sold, the more people that drown. And you start to think, well, that's silly. Ice cream doesn't cause drowning, and it doesn't. What drives both relationships is a third unseen factor, which is the sun. Sun drives this right over here, more ice cream, and more likely to be in a body of water where you would drown. And so there's a third thing, and I could predict drownings all day long from how much ice cream was sold. That predictive capability is still there, but I can't say that the ice cream is causing the drownings. I hope that section made sense. Okay, the fourth method I have to spend a little bit more time on, but it tries to overcome the limitations of the previous methods. One of the correlation is you couldn't say that ice cream caused drownings, or I play less video games and it causes me to get an A. And so I have more control than I do in the outside world. That's why basic research is usually done in a laboratory, because in the outside world, there's all these suns floating around that could mess up my experiment. And I think, oh, okay, ice cream is not causing drowning. It's the sun, right? And it's really not the sun. The sun just makes it more likely that you would drown. Okay, and so in an experiment, I can control the temperature and all kinds of other things. And so I can tune that out as a possible explanation and say, yes, X caused Y. Now, if I was teaching methods, I would go into that in a lot more detail. Now, the scientific method, I don't want to get all Bill Nye the Science Guy on you, but usually let's say I make an observation. Let's just say that when it gets hotter, I think people are more aggressive. So I do some research on this. And lo and behold, it seems like that's true. So I come in and I'm going to make my own experiment. Remember, we're talking about experiments. And so I first of all start off with a prediction or hypothesis. If you have to take stats, you'll have to test the null hypothesis. Now, my hypothesis is that hotter temperatures will lead to more aggression. Now, I bring this into an experiment. Maybe I make 2 rooms where one is really hot and one is not so hot. And then I see how do people act in these 2 rooms. And if this backs up my prediction, maybe I can say, oh yeah, I start to develop a theory about heat and aggression. I might have to back it up multiple times, replicate it. I don't want to get into all of that, but you see where I'm going. Okay, 2 things I want you to know for the test for sure. Number 1, independent variables. Independent variables are how I treat people. Dependent variables are what are the effects of this treatment. Now, what does that mean? Well, if I shine a light in your eyes, I treat you a certain way, you might squint. And the reason it's dependent is because it's dependent upon what I did to you. If I didn't shine the light, you might not be squinting, right? So X causes Y. And a simple example of X causing Y, the shining the light causes this, unless all of a sudden the sun came in the window while I wasn't looking, but I could control that. So I'm going to say X causes Y. There are sometimes hidden variables in experiments. We call them confounds, just like with the ice cream drowning example. I didn't know I had this on here, but I don't want to go off on Big Pharma, but I do. I have this love-hate relationship with it. It's like I hate being on my medicine. Okay, but let's just say I work for Big Pharma and they want to test out 2 new drugs to see if they're efficient. They do, well, maybe they would make some groups. A placebo is like a sugar pill. So this is going to be like my control group right here, where I just give them a sugar pill just to see if just taking a pill does anything, because there are placebo effects. People just think they're doing something. We're talking about psychology, right? If we were in class again, I would go into more detail about this. But here's my 2 drugs I'm testing. And that's why this is sometimes called, if I can get this to come on here, the control group, right? Because this is kind of doing nothing. That's my benchmark if you're in business against the other 2. And so this is my experiment. Which one is okay? So in this experiment then, the independent variable is how I treat these 3 groups differently. If I treated them the same, it wouldn't vary. It would be static. That's why it's a variable, right? It's changing. And so that's the treatment. Well, what's the treatment? Which pill I give them? That's why I use the medical example. If I give you a different pill, hopefully you have a different reaction. The effects are how you react to it, right? I took the red pill and I started having a bad trip. You know what I mean? It's like whatever it is, it's like that's the effect of the drug that you took. Okay, hopefully that makes sense because I did something. Usually in psychology, we break people into groups and we treat them differently to see what happens. If we treated them all the same, what's the point of breaking them into groups? Here you can see all of a sudden drug B is a lot better than drug A, and drug A is just like the control, which would be just like, I thought I had this on here, the sugar pill. So I'm going to invest more research into the red one. This doesn't seem to be efficacious at all. And so hopefully that example made sense. My second example, Liebert and Barron. This one's a lot easier. It's about one of my favorite things, TV violence. I love TV violence, but there's a big initiative in the 70s and 80s, especially with the PMRC, and like music. I mean, I listen to a lot of heavy metal. They're getting so mad at Ozzy Osbourne, all these people back in the day. Okay, so they divide these children into 2 groups, and guess what? They're not going to treat them the same. Why? Because it's a variable. What did they do? One group of kids watch a clip from a horse race. Another group of kids watch a clip from a gangster movie. You don't watch the same thing. Now they want to see, does this have an effect on their behavior? Effect, dependent. Hopefully you're following. And so what do? Well, they take the kids out to the playground, but on the way to the playground, they'll pull one out every so often. They'll say to the kid, hey, do you see these 2 little buttons? You see your friends on the playground? If you punch like this green one over here, then you would give them a treat. But if you punch this red one, they might get a shock or get in trouble. So you can punch one. Nobody's looking. I won't look either. And then they see what kids do. Does the type of movie affect the... So they didn't see the same kind of movie, right? They saw different movies. Gangster, horse race. And now it did affect which button they punched, because the little kids that watched the gangster movie were more likely to punch the red button. There was some kind of an effect of their the video they had watched on their behavior. These are just a few issues to consider when you're doing an experiment, things that either might mess your experiment up or ways you can take the research. Okay, so random assignment. What does this mean? Well, when I make these groups of people, the groups of kids, let's say I show one of them a gangster movie, right? One is like I showed the horse race. Well, let's say I accidentally put all the girls over here and all the boys over here in this group 2, and group 2 saw the gangster movie. And then later on I say, see, group 2, the gangster movie caused you to punch the button. It's like, no, it doesn't. It's because they were all boys. You have to have this 50-50 shot of being in both groups. And so that's why I call it shuffling the deck. And it's not just with gender. It's socioeconomic status, race, all these other issues too. And generalization has to do with how do we take the results of the research. This is one of my problems with science. Now, if I find the kids punch the hurt button, now I might want to go into this campaign where we got to outlaw all gangster movies because they're bad and kids are going to do bad things once they see them. It's like, well, maybe we need more research. That's one specific study, and now you've taken it too general, overgeneralized its findings. This is my problem with the news. Every 6 months, it's like, oh, a glass of wine a day is good. Then 6 months later, no, it's not good. Or it's like, this causes cancer. No, it doesn't. It's like, how about get 1,000 studies together that point in the same direction? So this is taking the results too far. This is shuffling the deck. Next few things you don't have to remember for the test, but we have to keep your results a secret. I can't say John Smith did this in my study and go tell everybody. I can say men did this and women did that in general terms. You have to know what you're getting into. It's kind of like skydiving. I can't go, I want to see the psychological effects of putting you into a casket with a bunch of cockroaches. It's like, no, it's like you have to agree to it and know what you're getting into. We'll deceive people, but it's more deceiving to cloak the intention of the study. And if we cloak the intention later on, we have to say what we were really studying and why we told a fib. Sometimes people aren't very good liars, though. So if you give away clues that let participants determine what the experiment is really about, this is why people lie in experiments. Not really lie, but they try to cloak the intention. Is that people will sit around going, I'm in a psychology study. What do they want me to do? Either I'm going to do one of two things. Okay, I'll just do what they want me to do, or fuck that, I'm not doing that. I'm going to do whatever I want to do. You know what I mean? Screw them. And so that's what I think most people do. And that's why I think we as psychologists can't go, telling other people, because other people watched. And this goes to one of the last things in this section, which comes from the Hawthorne Works division of the Western Electric Company back in, I think it's the 1930s. You don't have to remember this for the test, but they sent in all these psychologists, industrial kind of guys, and they wanted to try to increase efficiency at the plant. And no matter what they did, workers worked harder. Work at night, work in the morning, hotter, colder, shorter hours, long, it doesn't matter. That's because they knew they were getting watched. If you know you're under surveillance, of course you're going to work harder. You know what I mean? And so that's my problem with psychology experiments. Sometimes you know you're getting watched. You're not going to act natural like watching an animal in the wild. And so a lot of times these laboratory experiments that we create, even though I'll talk a lot about them, sometimes they're a little phony because people know that they're in an experiment. I hope that section made sense as well. Wow, I was losing a little bit of steam there. This is the last section. There's only 4 slides left. Qualitative. Quantitative research, numbers based. Qualitative, I'm going to say, is more words or descriptive based. She has red hair. Okay. Ethnography. I have Margaret Mead on here. Ethnograph. I'm graphing out an ethnicity. What does that mean? I go and live with the people, and I immerse myself in their culture. And then what she did is back in the 1930s was way ahead of her time. As a single white woman to go over to Papua New Guinea and live with these, native people, she wrote all these books about how men and women acted within their cultures. And some of the books she would find that, or some of the cultures I should say, she would find that the men were real gentle and meek and the women were ruthless. Or in other cultures, only men could play with the babies or wash the dishes and not the women, which is very odd compared to the way the United States divided labor between men and women and saw the roles of men and women. None of that had numbers, but it was very interesting. Another area that I kind of get into ethnography is because of my religion class. I talk about cults and gangs and how they bring members in, and a lot of times people will either pretend to be a member and infiltrate the gang, or after they were a member, like Leah, what's her name, Scientology, they get out and they tell you everything that was going on inside. Okay, that's what I love. You know what I mean? I want to know what was happening. None of that has a lot of numbers, but it has a lot of richness with verbal. The second thing is case studies. Case studies is, let's say I work with an individual or a group of people over time. Maybe I'm a doctor. I see you over and over. Or I'm a therapist. I see you over and over. And as I see you over and over time, I start to notice things in your behaviors. Tim, you're getting a lot better in this area. It's like, yeah, but that's not a number. Can you give me a number and quantify that? No, but I can notice that you're getting more confident. Yeah, but you can't quantify it, so it doesn't make any sense. It's like, but over time, Tim, I can see the change in you. You see what I mean? And so as I like work with, let's say if I went to a therapist that worked with people that just got out of divorces and say, well, what's the most common hurdle right away? You know what I mean? And they would like throw something out. It's like loneliness or something. It's like, okay, well, that's not a number. It's like, yeah, but that's where I'm back to the she has red hair. Okay, so I hope that I made sense. One of my favorite people that was a person that did case studies, looked at individuals over time, his name is Sigmund Freud. That's all he did. Looked at neurotics and psychotics over time. They came to his office over and over and over. And then after he watched them over and over time, he wrote all his books. And it's like you either love him or hate him, but he had a big influence just based on this kind of case study method. I got a little draw happy there. Last one is an interview where I bring in an expert and I trust the expert more than my opinion. Now, this is one of my problems with the news because, like, I don't need an expert to explain what happened. I know what happened. Just tell me what happened. You know what I mean? But if my tooth is hurting, I'm not going to trust my opinion. I think I might trust my dentist's opinion. If he says I need a root canal, I don't go, well, you didn't say 87 or 132. I need a number. It's like, dude, you need a root canal, you know? And so, his opinion is better than mine. Okay, so this is just, trusting experts because they can shed more light onto a situation. Okay, I hope this second lecture made sense. I'll see you next time.